Okay, sometimes you need to calculate the concentration of either an ion or a compound after you've mixed two solutions. This is particularly useful when you're determining whether or not a precipitate forms, but it could be a standalone problem by itself also. So, if you remember, molarity is mole solute per liter solution, and also when an ionic compound dissolves, the dissociation occurs. So if I'm finding the concentration of a particular ion after mixing, I need to take into account dissociation. For example, if I'm mixing calcium chloride, I'm going to get 2 moles of chloride ions for every mole of calcium chloride that I mix. Also, when you mix two solutions, you get a new volume. So everything gets diluted. And so it becomes a combination of a mixing problem and a dilution problem. Here's what it might look like. What's the molarity of chloride ions in a mixture formed by adding 100 mils of 0.15 molar calcium chloride to 50 mils of 0.2 molar sodium chloride? Assume volumes are additive. So in order to do this, I need to find how many moles of chloride ion are in the mixture, and then I also need to take into account that my new volume is 150 milliliters because it tells me to assume that volumes are additive. So I'm going to first count how many moles there are in 100 mils of 0.15 molar calcium chloride. So 0.100 liters of solution times 0.15 moles CaCl2 per 1 liter of solution. And that gives me the moles of calcium chloride, but now I need to take into account dissociation because I've been asked to find the molarity of the chloride ions. So I need to say that there are 2 moles of chloride ions for every 1 mole of CaCl2, and that's going to be 0.0300 moles of chloride. And now I need to take the other compound that I put into the beaker, which was sodium chloride, and count how many chloride ions were in it before I mix them. So I have 0.500 liters of solution times 0.2 moles NaCl per 1 liter of solution, and then 1 mole of Cl minus per mole of NaCl. And that's going to equal 0.0100 moles of chloride. Now, these two got mixed, right? So I took the CaCl2 and I took the NaCl solutions and I put them into one beaker. So now in that beaker I have a total of 0.04 moles of chloride ion. So my moles of chloride ions are 0.030 moles Cl minus plus 0.010 moles Cl minus, and my new volume is, we assumed that they're additive, now the new volume of the solution is 150 mils. So, because 0.1 liter and 0.05 liters is 0.15 liters, or 150 milliliters. And so when I do that, I get 0.267 molar Cl minus. Okay, hope that helps.